All right, so now what we want to do is create a series of scales that will take this data here and then turn it into a nice scatter plot over here. So across the bottom, we're going to do GDP per capita, and going up and down, we're going to be doing life expectancy. We are going to set the size of every circle related to the population of that country, and then we're going to color it based on continent. So we're going to need 4 different scales. We're going to need a color scale for the continent. We're going to need a exposition scale for GDP per capita, Y position scale for life expectancy, and a radius scale for population. So let's start with first just making sure all of these circles are there. So my favorite thing to do is to first just start off by saying, let's make sure we can see all of you and we can give you an X and a Y and an R. So I'm saying all of you get the same R, all of you get the same CX and same CY. So remember that for a circle, it is CX and CY. For a rectangle, for text, for everything else, it is X and Y. So this should give me a bunch of circles with a radius of 10 at 10, 10. Refresh, and okay, there we go. We got a bunch of circles all up in that left-hand top corner. So let's build these scales one at a time, just so we can kind of see everything take shape. The first thing we want to do is we want to create a scale to space these out over the x-axis using GDP per capita, this column right here. So usually when you build your scales, you build your scales after you create your SVG, but before you read in your data. So I'm going to call this the exposition scale because it's setting the x position. And it's going to be a scale linear because it's always a scale linear. And now I need to think about what my inputs are. So the smallest possible GDP per capita that a country could have is 0. But what's the largest possible GDP per capita? Like, I don't even know. Like, it seems like what we should be doing is saying, hey, once we read in the data, maybe we can figure out what a good GDP per capita is. But right now we haven't read in the data. So let's just shelve that for a moment. Let's say, okay, we don't know what the domain is going to be. We don't actually, let's just make something. Let's see, where's Luxembourg? Because I know they have the biggest. All right. So we'll go between 0 and let's say 70,000. So our domain is between 0 and 70,000. And our range, our output for this exposition scale. If you have a GDP of 0, we want you on the far left-hand side, which is 0. And if you have a GDP of 70,000, we want you on the far right-hand side. So that is going to be width. So remember that we could say 800, but let's say we ended up changing the width later, it's going to be a lot easier to use that variable there. So this scale will, in theory, take a number between 0 and 70,000 and then give us a number between 0 and width. So let's just test it out. So exposition scale, let's give it 35,000 and see what it says. Open up our console. Sure, gives us 400, which is halfway between this and this. So beautiful, I love it, everything's perfect. So here's what we want to do. We want to say, okay, your CX is now based on this exposition scale. We want to change our CX for every single one of our data points. So we're going to throw in a function d instead of just a number. We have to type return because it's the most important thing ever. And then we need to think what scale is related to what column. So we're going to say our exposition scale is related to the column called GDP per capita. So it's d dot GDP per capita, save, refresh, and there we go. It is now evenly spaced these out. Now, we want to do the same thing for our y position scale. The issue is this is really just a long graph, so I'm going to make it a little bit shorter. Let's say I make that height 300 instead. So it's fun that just by changing this variable here, suddenly the height of my SVG appears, and anything else that depended on that would also change. So we now need a y position scale to work across our y-axis here. So all I'm going to do is I'm going to cut and paste this, and I'm going to change it to a y position scale. Our domain. You can live 0 years, or you can live, I doubt anybody lives more than 80. And for output, we think, between 0 and height. So this is my favorite thing about D3, graphing, and SVG, what we're about to do right now. It's a horrible thing, but it's how it goes. So for our y position scale, we are going to honestly just cut and paste this over top of our cy, and then I'm going to change this to be cy, y position scale, d dot life expectancy. Life expectancy here is going to match my life expectancy column right here. And let me just double check that Japan's life expectancy, it's 81, so we actually have a problem here. So let's change our life expectancy maximum to 85. Talk about how to fix that up later. Okay, so we're now saying, please set your center y using the y position scale and feed it life expectancy. So give it a number between 0 and 85, and you'll get back a number between 0 and height. So we're going to save, we're going to refresh, and we see this. We see a very odd graph where, here, let me make the radius a bit smaller. We see an odd graph where as you get a higher life expectancy, or as you get a higher GDP, your life expectancy seems to go down. The reason is that when you are dealing with SVG, 0, 0 is the top left-hand corner. We're used to 0, 0 being the bottom left-hand corner. So what this means is every time we're dealing with a y-axis, we need to actually flip our scale. So what we want is, if you have a life expectancy of 0, you should be down here. If you have a life expectancy of 85, you should be up here. What is the y value up here? It's 0. What is the y value down here? It's actually height. It's actually 300 down at the very bottom. So we need to say, if you have a life expectancy of 85, we want you up here at 0. If you have a life expectancy of 0, we want you down here at height. So save, refresh, and there we go. It has now flipped around and life is good. Now, we did have a problem though, where when dealing with Japan, it had 81 point something as its maximum number. And we had to manually go through our data in order to find out what that biggest number was. We can actually do this inside of here. So we made our X and Y position scale before we read in our data, because that's just the way people do it. Probably because you can see width and height and it's close by. I don't know. But the idea is we can actually update these scales after we've made them. So after we've read in our data points, if we can find the maximum life expectancy or the maximum GDP per capita, we can then update our scale to say, no, our domain isn't 0 to 85, our domain is something else. So for example, I could say y position scale, domain 0 to max expectancy. I could have a variable called max expectancy, and I could say it's, 100. So now I could actually get rid of this right here. So up here at first, I'm only giving it the range. I'm only giving it the output. If we had domain there, that would be fine too, but it's good to look at it and realize that you don't set it initially. So I'm reading in, I'm setting it to say, look, I'm having a scale, and I don't know what the input is going to be yet, but the output is going to be between height and 0. And then once I've read in my data, we'll calculate this number later, but then I can update my scale here. So when I refresh this, we now see it shifted down a little bit because this is 100 here. In order to figure out what the maximum life expectancy is, I have given you a file called snippets.txt. Snippets.txt gives you all sorts of very nice things that you can cut and paste. You will probably just need the first 5 or 6 of them. So right here, we have something that says the maximum value of something, which says d3.max cities, function d return d.population. So I'm going to copy and paste that. So this code right here goes through the cities variable and then finds the biggest population. What we want is to go through all of our data points and find us the biggest, what scale is this? Y position scale, the biggest life expectancy. So anytime you want to find the maximum, you'll use code that looks like this. Next week, we'll figure out how to make this part look a little bit fancier, but for now, just survive with this. So we'll save, we'll refresh, and now we'll see that Japan's really running off the edge there, but we'll ignore that for now. We can actually do the same thing here for our exposition scale for the GDP per capita. I'm just going to copy and paste this code here, and I'm going to say max GDP, d3.max, sure, go through all of the data points. We want the maximum GDP per capita column. We're going to update the exposition scale to be between 0 and max GDP. We save, we refresh, and that went terribly, terribly, terribly wrong. Now, what ended up happening here? This is my least favorite thing about D3. It seems like this should have worked fine, right? We looked at all the countries. Luxembourg has a GDP of about 64,000, which is a lot more than the other countries. So if we look at max GDP, we're going to save it, we're going to refresh here, and look at our console. So it says that 982 is our maximum GDP, which seems weird because, 64,000 is much, much, much more than 982. Now, if you remember the joys of sorting in pandas, you might recognize the fact that this number starts with 9, whereas the one that we were working with before, the Luxembourg's largest number is 64,000. And yes, when D3 read this data in, it read it in as strings. Even though they're obviously not strings, even though they're obviously numbers, pandas will look at a column and figure out what it should be. D3 will not do that. You have to say, this is a number. The way you do that is just put a little plus sign. Just put a little plus sign. And it's like there are other ways to do this in JavaScript. They're all way more complicated. This is just, it forces JavaScript to understand life expectancy as a number. It forces JavaScript to understand GDP per capita as a number. We're going to save, we're going to refresh, and there we go, looking beautiful. Now let's do our scale in terms of the radius. So we're going to make a new scale, var radius scale equals d3 dot scale. What kind of scale is it? It is not a scale linear. Every time you use a radius scale, we're basing this on area, so scale square root. Do we know what our domain is? No, actually. We'll just say, look, we want an output between 0 and 100. We are going to figure out what the what the largest possible radius is once we actually have read in our data. So same way we did before. So this is going to be a very, very, very common pattern for you, where you create a scale, you say D3, here's the kind of scale I want, here's my output. We don't know the domain yet. We update the domain of the exposition scale down here, so to avoid getting confused later, I'm just going to delete it right now. I'll say, let's set up our scales along with their outputs, and then I'll make a comment in here. Let's update our scales so they know the input values. So what we want to do now is we are going to, the radius is going to be the population. So the population column is the one we're interested in. So I'm just going to copy this and say max pop. Sure, d3.max, go through our data points, find the largest population. Update our radius scale to be somewhere between 0 and max pop. This is why you end up cutting and pasting so much in D3, because this looks the same as this, looks the same as this, and even if the code itself looks confusing to you, like D3 max, how does it work like that? Why does that happen? You don't need to know. Basically, it's going through data points, it's pulling the population out of each of them, and then it's getting the maximum. But honestly, in the end, as long as you know this pattern will find you the biggest number and then update the scale, that's kind of all you need. In the same way that instead of R4, we could say function D blah blah blah. Honestly, you're just going to have typos if you do that. So what we're going to do instead is copy and paste this and then change them one by one. We want to change the radius attribute. Function D, yes. What scale are we using? The radius scale. What column are we using? Population. So now the population feeds into the radius scale and updates the R of our circle. Save, refresh, and there we go. That looks horrible. Let's actually make that maximum a little bit smaller. So let's say a number between 0 and 20 maybe for our radius scale. Save, refresh. We can go a little bit bigger. We'll go up to 30. There's also the problem that these are overlapping on top of one another. So what we can do is attr opacity, and we can drop the opacity down to maybe 0.3 so that we'll be able to see through every one of these circles. There we go, that looks a little bit nicer. And now we have one more column we need to pay attention to. We need to pay attention to the color. We're gonna table that for a second though, because it ends up causing a few more problems and there are a few more hoops that we can jump through. Or, yeah, let's do it. So when we set a color scale, we're gonna be calling it color scale. What kind of scale is a color scale? Well, before we used scale linear because we were attempting to associate a number such as population with a color such as, we said, you know, if you're the smallest country, then, or if you're the smallest city, then your color is going to be beige. If you're the biggest city, your color is going to be red. This is different. This is different because we are giving it a bunch of different country names. We're saying, or continent names, Asia, Europe, Africa, South America, North America. We're not giving it a range. We're not giving it a number. We're just giving it a bunch of different values. So if you go through the list of scales you will see that one of these is called scale ordinal, which is for relating a category to another category. So in this case, we have one category, which is the continent name, and then we have another category, which is color. So we're going to be using scale ordinal for this. So d3.scale ordinal. Normally we give a domain and a range. So we would say North America, Asia, etc., etc., etc. When you use a scale ordinal, you don't actually have to do this. You only have to do that if you care about which colors or which inputs are associated with which outputs. I don't care, so I'm just going to list some colors. Red, orange, yellow, blue, purple, green, pink. It's a terrible color choice in this case. Black. I don't know how many colors there are. We'll talk more in the future about picking colors and using D3 to pick colors, but for now what I'm saying is D3. Make a scale that can take in a category. When you get a category, give back one of these colors. Give back one of these other categories. And once it has seen a category for the first time, if the first category is Asia, it's going to say, okay, I'm always going to use red for Asia. And then if after that it sees South America, it's now always going to use orange for South America. So I'm going to take this color scale, I'm going to go down here, and I'm now going to say attr fill function d return color scale d dot, I think it's continent dot continent. Yep. So that will take the continent column, relate it to this color scale as the fill color. So save, refresh, and there we go. We got beautiful little guys there. They could probably use a little bit of a stroke so I can see them better. So maybe I'll attr stroke black. That looks a little bit nicer, I think. All right, a couple final things we need to change. The big problem is we don't have any margin on the side. We don't have a title. We don't have any labels. Like, who knows what's going on in here? You know, like, does this end at 100? Does this end at 50? What is a large life expectancy? In order to fix this problem, we are going to go in snippets.txt. So snippets.txt has this thing called the margin convention in it, and you don't need to read it. Don't read it at all. Just copy it and then paste it after we create our SVG. So it's a delight. The things we're going to change here. Width and height both have a number next to them. We're going to copy our width and height into that. So our width goes there, our height goes there. Delete. Right here we're creating an SVG. This also seems to be creating an SVG, but doing it much more complicatedly. All we're going to do is say, okay, we're doing d3.select pound chart. So we're going to change this to d3.select pound chart. And then I'm going to delete, and I'm not even going to look at this anymore. I'm just going to save and refresh. So we now have a little bit of a boundary on all of our edges. What this code allows us to do is set the height of the total box. So height 400, make it a little bit taller, sure. Height 200, make it very, very small. But then we can also shift around these margins on the left and right. So right now, let's say we had a left margin of 0. These circles would go off the edge. In order to push the circles to the right a little bit, we can increase this to, let's say, 30 pixels of margin on the left. So it doesn't change the actual size of our SVG because of this math here. All it really does is change the size of the drawing area inside. Now, why do we do this? The real reason is because we need axes on the left and on the bottom. The way that we add axes is we just take this code. You never have to read this code. And we put it down where it says, always cut and paste the code for the axes. So all this code does is it takes our y position scale and our x position scale, which we've magically named the same thing, and we will always name the same thing every time we do a viz. We save it, we hit refresh, and now, hey, look at that. We now have axes that go on here, so we understand what's going on the left, what's going on the right, what these numbers actually mean.